So let's start our lecture 16. In this lecture 16, we are going to discuss detail velocity time graph. Okay, so one thing you have to take care if we are discussing our velocity time graph. In last videos we have covered speed time graph. In case of velocity time graph, the first thing you should notice, velocity is vector quantity. Okay, vectors can go negative. Okay, don't worry for this. But if you compare this with speed, whenever you are drawing a speed time graph, speed part will never go in negative direction. For example, if this is my speed versus time, I can never draw a speed which will come in negative side. No, this portion is totally wrong for a speed curve. But this portion is valid in case of velocity. Okay, for example, suppose I will go into detail. Let's take one small, very good and very common example taken by all physics professors. Suppose you are throwing a ball upward. If you are throwing a ball upward, then in the beginning itself you are giving very fast and as max as possible speed. Then only ball will start from here and it will reach to a height, right? So from here you are starting. Suppose you are throwing with the ball, suppose you are throwing the ball with 100 meter per second speed. So at maximum height, ball is reaching and being with zero velocity. Here velocity became zero, correct? It means what? If you check in the beginning itself, velocity is decreasing and finally being zero. So this thing I can discuss in two ways. In terms of speed also I can discuss, and in terms of velocity also I can discuss. So let's discuss in terms of speed. So if this phenomena I will discuss in terms of speed, then in the beginning my speed was highest, that was 100 meter per second, and then I will draw a line like this and I will touch here exactly 0. Okay, and a particular time will be taken there. Okay, to do so, to reach from here to here, particular time will be taken. That time we can easily calculate. Okay, I am not teaching how to calculate time, because right now I am not teaching you those equations of motions. I will come to that, don't worry. Right now I understand. See, when time is increasing in this direction, your speed is decreasing, correct? Okay, so till here I am considering in this direction, when your height is increasing, in this direction, I will consider my height is increasing and my velocity is decreasing, and acceleration, which is motion under gravity, so acceleration is constant, that is a is equal to small g. These three things I will keep in mind, and after that I will judge. Right now, if I will find out slope of this curve, then slope of this curve will be positive or negative. Slope of this curve will be positive or negative. Okay, some of the student may think, sir, why can't we draw this curve? Okay, so, or why can't we draw this curve? So first thing, always keep in mind, this is your time parameter. Time parameter can never come to negative side. So either this side or this side you should not draw the curve. Only this side or this side you are free to draw the curve, whatever type of curve, if time is there. One thing, make sure. Now next part. Okay, this is my speed time graph, and if I want to judge velocity time graph here itself, then how can I judge velocity time graph? So always remember. Now first part over, and now I'm going to discuss velocity time graph. So the same line will represent velocity time graph also, same line, because right now I have considered in this direction my velocity, in this direction I have considered as my positive direction. See what I'm saying? This direction upward I have considered my positive direction. Why? Who am I to judge the upward direction positive? No, reality is you can choose downward direction positive also. Now, but why direction is coming into picture suddenly? Because guys, velocity is vector quantity. So without deciding direction sign, if we are judging the topic or if we are doing a numerical, it is totally our fault. Okay, so whenever we are discussing any kind of vector quantity in physics or in science, we should know that vector quantity will be having direction. So if this direction is positive, then this direction is negative. So what kind of variation is there? Based on this, we'll pick the sign. So I am throwing the ball upward and ball is reaching here. So this is the maximum height ball can achieve. So when you are drawing a speed time graph, then it comes like this, a speed time graph, done, correct? But if you do velocity time graph, that will also be in same direction, exactly similar like this. It's like same line will be copied, same line. But imagine if this object is coming down back. In that case, what will happen? In that case, your speed will further increase. And make sure speed is scalar quantity, it can never be negative. Even though direction is downward, but it can never be negative. Okay, so what will happen? This speed time graph, what you have done here till here, from point A to point B, then further your speed time graph you will draw like this till here, because when ball will come back, it will again regain 100 meter per second speed at the bottom. Why will it regain the same speed? Because from here kinetic energy converted into potential energy at maximum height, and the same potential will convert further again into the same kinetic energy, right? That's why you have same velocity. And of course we are not losing the mass is coming back, the total mass is coming back. Okay, that's why kinetic energy will be same. Anyway, that is the next part. Come back here. So why I will choose this line? Why will I choose that line? Answer is very simple. Because the portion from B, suppose this is your ground level, I am saying as A, and this is your highest level, I am saying as B. So A to B, this line, then further like A to B gone, done. Now you're coming B to A. So when you're coming B to A, so of course you are taking the time. So this time and this time will be same. Again, this time and this time will be same. And you will also gain the same height. So whatever height we have here, same height. If this height is 100, then this height will also be 100. Okay, so this will be your graph about speed. But if the same situation I want to draw for velocity, you will be shocked. In case of velocity, what will happen? See, the first A to B part will be like this, as it is, like touch here, as it is, like this. But after that, your direction is being changed. When you are going upward, you are taking positive, but when you are coming downward, your velocity should be negative because of direction consideration. We are considering the direction. So if you are starting from 100, then you will further go such that on this axis you will cut 100. Okay, so this will be your velocity time axis. You have to feel everything. Whenever we are talking about speed, speed has nothing to do with the direction, only magnitude part should increase or decrease. But in case of velocity time graph, you have to think about magnitude also. You should reach to 100. You should reach to this 100, and direction wise also you should satisfy the main concept. I hope totally going well, right? If this is not velocity, this is the speed, then you will draw like this. Clear? I hope it's clear. So if I have velocity and time graph like this, what does it mean? Meaning is very clear. Time is increasing, but velocity is constant. Velocity is constant, so motion is there or not? Of course motion is there, because if velocity is constant, it will be having speed also and direction also. Both are constant. Speed is there, right? So of course motion is there. So first part, motion is there. What kind of motion? Uniform or non-uniform? Of course uniform, because at this point, if you draw the slope, suppose I am drawing at this point, I am drawing the slope. At this point I am drawing the slope. At this point drawing the slope. What is happening? Theta is equal to 0. Theta is equal to 0 everywhere. So slope of VT graph is acceleration. Acceleration is 0. So uniform motion, no doubt at all. Now go ahead. See here now. Excellent job. If I am drawing this kind of VT graph, velocity time graph, what does it mean? Meaning is very clear. But what does it mean? Meaning is at this time you have this velocity. Okay. At this time you have this velocity. It is very similar to speed time graph. Correct? Okay. So velocity is having same slope at this location and at this location. So slope of velocity is constant. It means your acceleration is constant. How will you know slope of velocity is constant? Slope of velocity is nothing but dv by dt. So slope is constant everywhere. Because why? Because theta is constant. Theta is constant. And one thing, why I am drawing only this line and this line? Because I am drawing line parallel to x-axis so that I can find out angle. Remember, we always in xy axis we always cover angle this side anti-clockwise positive. Okay. Anyway, that is the next thing. So this was the VT graph, very excellent VT graph. And of course, this kind of vertical graphs are not possible in case of VT also. right? And just now you can cover for this part also. If you have this kind of line, then in case of VT, same line will represent acceleration. I mean, at this point your slope will represent acceleration, at this point your slope will represent acceleration. But the point is, this acceleration and this acceleration is not same, and this acceleration, because you are increasing, so this curve is increasing, so acceleration is increasing. You have to pause the video and write down everything in detail and understand. If your acceleration is increasing, that property we call as jerk. So in this graph you have jerk. Okay, I hope totally clear. So in same way you can have this kind of velocity time graph as well, right? So this is one graph what I explained here. This is another second graph. It can go like this, right? In that case it is decreasing, 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 decreasing. It means what? Velocity is increasing but acceleration is decreasing. Why? Because slope is decreasing, right? Okay, now try to answer this. You have like this, correct? What does it mean? Meaning is, okay, you have to say the meaning. This is a velocity time graph, and after that I am drawing this line. Now explain the physical situation, like what kind of physical situation you are able to see here. So see here, physical situation is very easy. You have to explain that situation. In this graph you have to assume any example, and that example you have to comment in the box. And only very few students are watching the video and commenting, and I am immediately replying to their comment. You can see in the description I have a WhatsApp group. You can join my WhatsApp group using that link, so we can have some chit chat there in WhatsApp as well. Okay, don't worry, I know you guys are in 11th class, 12th class, you guys are very like childish. No problem, just come there, join the group, and we'll study ahead. That's all. Now we are remaining with acceleration time graph. So acceleration time graph we'll take in next video. Let's see the next video.